Hi guys, and good morning or afternoon whenever you're watching this. I'm going to be giving you some notes today on Edpuzzle. It's not the best day ever, so for me anyway, but it's going to be a great day in class. I will be here with you. I might be in and out, therefore I have produced a video so you can still learn something no matter what happens today in class. So you all should have a paper that says Earth Plate Boundaries in front of you now. So today what you're going to need is this paper, a pencil, you'll need some scissors, and some glue. So you should all have that by now, and I'm going to show you how this is done on this Edpuzzle video. So let's get started. Here's your paper. The first thing you are going to do is write down the definition for plate or for transform boundary, just so I can make sure we're all talking about the same thing. I'm going to highlight the definition that I'm about to give. Transform boundary. I'm going to type in this definition right now as I talk about it, and excuse me, you are going to write it with your pencil. So, a transform boundary is when two plates move past each other. So they slide past one another. They kind of go like this. I hope you can see my arms. They kind of go like this. They slide past each other. So let's write down that scientific definition for plate boundary. I'm going to come in here. Obviously, you will be writing. I am typing. That's just how it works right now. And you will have to pause the video to make sure that you are able to get the definition. So don't worry about pausing it whenever you need to. So a transform boundary is I'm going to make that bigger for you, I'm sorry. Okay, is a place where two plates, wait a minute, two plates, that's definitely not the word plates, slip past each other, moving in opposite directions. So that's pretty straightforward. You've got these two plates, they're big rocks in our lithosphere, they're flat, and they move past each other, okay? But I want you to add something to this definition. Here's what you get. You get something called a fault. My goodness. You get something called a fault, okay? And usually this gives us very special things called earthquakes. Now, this is what usually happens at transform boundaries. I'm not saying that you don't get an earthquake in other boundaries, because you do, but this is what a transform boundary is famous for. When these plates slip past each other, you tend to have an earthquake, okay? That's just how it works. So, what you're going to need to do now is look at the pictures you have. This next column says movement of plates. So you're going to cut out the following picture. You're going to have a picture that looks like this. So I'm going to show you real quick. I'm highlighting it. I'm going to cut it out. I'm going to go back to my paper, and I'm going to place it right here. You need to pause this video. Whoa. And you need to do the same thing. Oh, not that. Hold on. You need to pause this video, cut your picture out, and paste it in this box. You can do that, and by the time you come back, I will have this picture in the right spot. There it goes. Alright guys, thanks for pasting that on there. Now, if you look at your picture, you will see that you have an arrow that moves to your right and an arrow that moves to your left. And these two pieces are known as plates. And this is showing you that the plates are moving past one another. Okay. Now, for your third column, the examples column, you will need to come over to your pictures, and you will need to find the picture that looks like this. And you can't see it, but I'm going to show it to you in one moment. So just bear with me. You need to find the picture that looks like this. I'm going to come over to my paper real quick, grab it. I know you have lines on your paper, but we're going to paste this right over the lines. Okay. Right there. So your picture will not have this red and white dotted line, but, excuse the bell, your picture will not have this red and white dotted line, but this picture needs to be pasted right here in the examples column for transform boundaries. Okay guys, so now that we have our information for transform boundaries on our paper, I want to show you some pictures off the internet of what a transform boundary could really look like on Earth. So, I'm going to switch my page. So we have a picture right here. And I'm going to move it into focus a little bit. This is called the San Andreas Fault. This is a real place. You can see that there's a crack right here on Earth. This is in California. And I can't tell from the picture, but what this means is that one side of the plate is moving one way and the other is moving this way. Let me show you a map real quick. I have a wonderful map picture somewhere. I can only find it. Let's see here. Map. I had a wonderful map picture. Here it is. This is the state of California. Maybe some of you have been there. This red line represents that fault. And as you can tell by this arrow, that this side is moving down or south, and this side of it is moving north or up. So we do have a major problem in California with faults. It is not uncommon to feel earthquakes there basically every day. So keep that in mind as you think about moving to California when you're older. You know, people there don't even realize that they're having earthquakes because it's so common, unless it's really, really strong. Okay. Okay guys, so that is our transform boundary. The next type of boundary we'll be talking about is a divergent boundary. So I'm going to highlight the word divergent and boundary so you know where we're at in our notes. And we're going to put in a definition for divergent. Now remember, you'll have to pause and you will have to make sure that you're pausing so you get this written down correctly. So in the divergent boundary box, we are going to give a definition, and here it goes. This is where two plates move apart and it usually happens at mid-ocean ridges, which where two plates move apart usually happens at mid-ocean ridges. So you usually get something when this happens. The area that they like to call this is a ridge. This word right here, a ridge, just without the S. They call this area a ridge, and it's usually going to happen underneath the ocean floor where you can't see it. So I'm going to make a few notes right here. I want you to write this down too. You will get a ridge and it usually happens under the ocean. And it forms mountains under the ocean. There you can actually go down there in some places and see the lava coming up that forms these oceans, or forms the mountains underneath the ocean water. So yeah, very interesting place. I'd like to show you some video on that as well. But let's talk about our middle column, the movement of the plates. So you are going to copy and paste, not copy and paste, you're going to cut a picture out that you have at your desk and paste it right here. So go ahead and pause this video, and we write down the definition, and I'll show you the picture in one moment. Okay guys, so you're going to go to your sheet, and you're going to grab this picture that I'm putting a box around. Okay, you will see in this picture that the plates are moving away from each other by these arrows, and you can also see, when I put it in here, you can also see that there's a little volcanic ash coming out. Now it says oceanic crust because, like I said, this is happening underneath the ocean water where you can't see. Like, you would never be able to go out and see this unless you dove down deep beneath the ocean and you know, took a look. So make sure you pause this video, copy and paste this. I'm sorry, I keep saying copy and paste. Cut and paste this onto your paper to show the movement of these two plates. Remember, they're moving away from each other. Go ahead and pause if you need to. Okay, so in the examples column for this, we're going to go back to our paper as well, and we are going to grab the picture that looks like this. I'm going to put a box around it. It looks like this. I'm not going to lie, guys, this is a terrible picture, but if you look at it closely, you can see that there's a wall over here of rock and a wall of rock over here, and there's actually someone diving down in between this, and that is where that is where a trench is located underneath the ocean water. Now, there are multiple trenches. I don't know what this one's called, but yeah, someone was brave enough to dive down there and, you know, explore. So what you're going to do as well is cut this out and paste this on the lines in the example column for divergent boundary. Now that you've had that pasted on your paper, I hope you've pressed pause. I want to show you a few pictures of what the trench could look like that's in color. Here's a beautiful picture of the ocean underneath. This is the side of the trench, or not the trench, the ridge that was created. This is called the Mariana Trench. It's about 7 miles deep. In places on the Mariana Trench, there is volcanic ash coming out. I could not find a picture that showed that, though. So there's many pictures online of this type of trench. Let's go back to our paper. The next paper, or the next boundary that you will need to write a definition for, is convergent. Convergent means to come together. And specifically what we're talking about is where the oceanic crust meets the continental crust. And I know you guys already know that those are two types of crusts. So we're going to type out a definition. Let's do that now. So the convergent boundary is a place where a continental plate collides with and make it grammatically correct, oceanic plate. Okay, where a continental plate collides with an oceanic plate. And this happens because the oceanic plate is more dense than the continental plate. So press pause, get that written down, and we'll go to our picture next. Okay, So the picture you're going to need, I'm going to have to find it because something happened to my computer. The picture that you need will be this picture. Let me find it for us. You will need the oceanic crust. Aha! This one. I'm placing a box around it right now. You will need this picture. Go ahead and make sure you cut that out with your scissors, and you're going to paste it onto the paper in the movement column. So let me get this moved into a better direction. Maybe I'm going to shrink it, maybe not. Here we go. Very nice. Copy or cut that out and paste it onto this middle column. I do want you to notice, guys, that on the left side it says oceanic crust, and on the right side it says continental crust. This crust is moving towards one another. That's what collide means. The oceanic crust will actually sink down underneath the continental crust, and when it gets down here, it melts. Okay, the whole process of convection starts over again. The next thing we're going to do is add our example. When this happens, we get something called a trench. So go over to your pictures, and I want you to find this picture of the sailboat, and I want you to cut it out, and I want you to put it onto your paper underneath the example side. I'm going to try to shrink it down so it fits nicely. There you are. And what I need you to notice about this picture is that there is, of course, water, ocean water. There's a sailboat, and then this dark line that you see in the background, it represents a trench. You cannot see it. It's underneath the water. So trenches is what you get, or I should say a trench is what you get when a continental plate collides with an oceanic plate. And I want to show you real quick. I thought I had a trench. I don't have a trench, okay? But that's what you get underneath the water. And a trench is exactly what it sounds like. It's a giant hole, basically, in the ocean. And you can kind of see right here the word trench. It's where there's like a deep V-shaped gap in the ocean. Let's go ahead and move down to our convergent boundary. I'm going to highlight it so you know where I'm talking about, or what I'm talking about. I'll put my text box in. This is where a continental plate collides into another continental plate. So let's write that down. It's when two continental plates collide. And here's what you get. The end result, we can see these in many places. You get mountains, okay? This is what you get. This is how mountains are formed when two continental plates collide. They both have the same amount of density, so they just crash into each other and they form a rock, which becomes a giant mountain. Okay, that's a pretty easy definition. While we're writing, I want you to go back up to convergent boundary, and I want you to write the word trench right here, T-R-E-N-C-H, because a trench is what you get when a oceanic collides with a continental plate. Okay, head over to your pictures. You should have two more left. You're going to find the one that looks like this. I'm going to put a box around it now. Here it comes. You're going to go over to your paper and take it and glue it in the middle column. And here it comes, maybe. Oh, that's my picture. Don't want to do that. Move myself to the side. Right here. And in this picture, you can see, I'm going to move my face over, maybe right here. In this picture, you can see that you have a mountain range that has formed when these two crusts hit one another. Collide means to bam, come together. And we have one last picture. I'm sure you can guess what it is. It's just a lovely picture of mountains. So go ahead and head over to your picture sheet and copy or cut. I keep saying copy because that's what I'm doing. Cut this out and glue it onto the last box you have available. Bam. Now, to end this video, I want to show you a picture of Mount Everest. This is the beautiful Mount Everest. It grows every year because plates keep pushing up against each other. And as you can see, there are some people who enjoy climbing Mount Everest. It's a very dangerous thing to do. Not something I'm personally interested in. Does not look like fun. First, it's super cold up there. Second, you have to sleep up there. And third, you could die. Not something I personally want to do. Maybe you want to try it sometime. I don't discourage it, but it takes a lot of conditioning and training to be able to physically, meaning use your body, to climb this mountain. If I'm correct, this mountain is like 38,000 feet tall. That's a big mountain. Okay, so going back to your worksheet, make sure your worksheet looks like mine. I am going to apologize. I know that there were some interruptions in this video, but I'm doing the best that I can. So, guys and gals, friends and pals, science students, make sure that you finish this video on Edpuzzle and turn in your paper when you're done. Thanks, guys. Bye.